Picture this, two spacecraft launched back in 1977, back when disco was a thing and bell-bottoms were like the height of fashion.
Wow.
These emissaries have traveled billions of miles, ventured beyond our sun's reach. And get this, they're still communicating with us.
Oh.
It's kind of like something out of a science fiction novel. But it's real.
It really is remarkable. Voyager 1 and 2 have just blown past all expectations. They've become humanity's farthest spacecraft. Like our envoys to interstellar space.
It's an amazing story. One full of incredible ambition, groundbreaking discoveries, and even a little bit of poetic hope for connection beyond Earth. Today, we're going deep into the legacy of the Voyager probes. We're talking their grand tour of the outer solar system, their incredible discoveries, and the message they carry for the rest of the cosmos. Welcome to Cosmos in a Pod, the Space and Astronomy series. So these probes weren't just sent out to, take a few snapshots.
Right.
What was the big plan for this grand tour they went on?
Well, the 1970s presented a rare chance, a planetary alignment. It only happens once every 175 years. It was an opportunity to use gravity to slingshot a spacecraft past Jupiter, Saturn, Uranus, and Neptune. Imagine like a cosmic billiard shot. This was Voyager's chance to change everything we knew about these giant worlds.
And they really took advantage of it, didn't they? Especially Voyager 2. It visited all four.
Yeah, Voyager 2 kind of became like the ultimate overachiever. It gave us this full picture of these gas giants and all their fascinating moons and rings.
Okay, so it's 1979, and Voyager 1 gets to Jupiter. What were some of the first big aha moments?
Well, Jupiter's Great Red Spot. That giant swirling storm that's bigger than Earth? It's always fascinated us. But Voyager 1 did more than just capture some amazing images. It revealed how complex the storm is, with all those swirling bands of wind and, turbulent eddies.
Whoa, it's like having a hurricane in your backyard, except this one's been going on for centuries. But there were other surprises too, right? Like beyond just Jupiter itself.
Oh, absolutely. One of the most shocking discoveries was finding active volcanoes on Io. That's one of Jupiter's moons. It completely changed how we thought about moons, and it showed us a new way planets can get internal heat, tidal forces.
So Io isn't just some cold rock. It's this fiery world being stretched and squeezed by Jupiter's gravity, and all that energy is erupting outward. That's incredible.
It's a perfect example of how the Voyagers made us rethink our assumptions. And speaking of assumptions, we got a much closer look at Jupiter's magnetic field. It's like this huge bubble protecting the planet from the solar wind. And Voyager helped us map it, figure out its structure and how strong it is.
Okay, next stop, Saturn. The ringed wonder. What do the Voyagers tell us for that celestial gem?
Saturn's rings are mesmerizing. There's no doubt about that. But the Voyagers didn't just capture how beautiful they are, they showed us how complex they are. We saw thousands of individual ringlets, gaps created by shepherd moons, and we learned that those rings are made of ice particles that range in size from dust grains to small houses.
Wow. So it's not just one big flat disk.
Yeah.
It's like this cosmic symphony of ice and gravity.
Exactly. And while everyone was focused on Saturn, one of its moons, Titan, started whispering its own secrets. Voyager 1 showed us Titan's atmosphere. It's dense and rich in nitrogen, and that hinted at the possibility of complex organic chemistry happening on the surface.
So that's when Titan went from just a dot on the map to a possible place for life.
Yeah, it definitely sparked our curiosity. And remember, this was back in the 1980s, long before the Cassini-Huygens mission landed a probe on Titan. The Voyagers basically planted the seeds for future exploration.
That's amazing. Now, Voyager 2 continued on its solo journey to Uranus. That's the ice giant that's basically spinning on its side. What did it find there?
Uranus is kind of the oddball of our solar system. It's tilted on its axis almost 90 degrees, so it's practically rolling around the sun.
Like it got knocked over or something? What else did Voyager 2 learn about this sideways planet?
Well, it found 10 new moons and 2 new rings, adding to Uranus's already unique collection. It also mapped the planet's magnetic field, which is tilted at a crazy angle and offset from the planet's center.
A sideways planet with a wonky magnetic field. Sounds like Uranus is a real rebel.
You could say that.
Yeah.
And finally, Voyager 2 reached Neptune, the outermost giant planet. That's where it encountered a world that was even more dynamic than we expected.
What was so special about Neptune?
Voyager 2 showed us Neptune's amazing blue atmosphere. It's whipped by winds that are faster than any other planet in our solar system. It found 6 new moons and 4 new rings, which just added to what we knew about these ice giants.
But the real star of the show was Triton, right? Neptune's biggest moon. I remember those pictures. It looked almost alien.
Triton was incredible. Voyager 2 saw nitrogen geysers erupting from its surface. They created these plumes of icy material that stretched for miles. Imagine seeing that.
It's mind-blowing to think about these freezing worlds having such intense activity. But the Voyagers didn't stop there, did they? They kept going beyond the planets.
They did. They kept going, pushing into that vast, unexplored territory of interstellar space. And that's where our story continues in part 2 of this deep dive.
I can't wait to hear more about that journey into the unknown. But before we go, I have to ask about the golden record, the one everyone talks about. It sounds like something out of a sci-fi movie.
It's quite a story, and we'll definitely dive into that next time.
All right, everyone. Stay tuned. We'll be back soon to continue exploring the legacy of the Voyager probes. Welcome back to Cosmos in a Pod.
It's great to be back.
It's hard to believe Voyager 1 and 2 are still out there, sending us data from so far away. Last time we talked about their journey through the solar system, but now they've gone beyond that, into interstellar space. What does that even mean? And how do we know they made it?
Well, it's like leaving the safety of our sun's bubble and entering a whole new realm. It's where the stuff between stars takes over, the interstellar medium. And it's not just empty space. It's filled with gas dust and cosmic rays.
So how did we figure out that the Voyagers had actually left our solar system?
It wasn't like they crossed a finish line. Scientists look for specific changes in the data. Voyager 1 crossed the boundary called the heliopause in 2012, and Voyager 2 followed in 2018. One big clue was a drop in the intensity of charged particles coming from the sun, and a rise in galactic cosmic rays. Those are high-energy particles from outside our solar system.
So it's like they sailed from calm waters into a sea of cosmic radiation. What have they been telling us about this place we've never explored before?
The Voyagers have been giving us a taste of what it's like out there. They're measuring things like the density temperature and what the interstellar plasma is made of. It's much less dense than anything in our solar system, but it's still a very active place.
So even in the vastness of space between stars, there's still stuff happening.
Absolutely. And it's not just about the particles. Magnetic fields are really important out there. They're like these invisible paths that guide cosmic rays and shape the structure of the interstellar medium. And the Voyagers are helping us map these fields, learning about their strength and direction.
It's like we're getting a 3D map of a place we've never been, thanks to these little probes. That's amazing. But wait, I remember reading about something called the IBEX ribbon. What does that have to do with the Voyagers in interstellar space?
Oh, the IBEX ribbon. That's an exciting discovery made by a different spacecraft. But it gives us clues about the region where the Voyagers are now. It's a band of energetic neutral atoms. It kind of glows like a ribbon across the sky. And it turns out these atoms come from the very edge of our sun's influence, where the heliosphere meets the interstellar medium.
So it's like a cosmic signpost, showing us where our sun's territory ends and interstellar space begins.
Exactly. It's almost like the Voyagers are sending postcards from a place we've only glimpsed through this IBEX ribbon.
That's a really cool way to think about it. But let's be realistic. Communicating with spacecraft that far away must be incredibly difficult. It takes like over 22 hours for a signal to travel from Voyager 1 to Earth and back.
It's really a testament to the ingenuity of the engineers who designed these missions. They had to think ahead, plan for everything, and program commands in advance because by the time a signal gets to Earth, things might have already changed on the spacecraft.
It's like playing a slow-motion game of chess across the solar system. And what about power? They must be running low after all these years. They can't just stop for a recharge.
They use those radioisotope thermoelectric generators, the RTGs, we talked about those before, but the plutonium fuel that powers them is slowly decaying. So each year they have less and less power. It's a constant challenge to decide which instruments get the energy they need.
So these aren't just voyages of discovery. They're voyages of survival. How much longer can they keep going?
Well, right now we think sometime in the mid-2030s they'll run out of enough power to keep even one instrument running. Then they'll truly become silent ambassadors, drifting through the galaxy on their own.
It's kind of sad to think about. They've been with us for so long, expanding our knowledge and sparking our imaginations. But there's something poetic about them eventually fading away. Like ancient explorers lost to the vast unknown.
There is beauty in that, I agree. But what they've done will live on. The data they've sent will be studied for generations, and their journey will always inspire us to reach for the stars.
And speaking of their impact, let's talk about the golden record. That famous message in a bottle attached to each Voyager spacecraft. What's on it? And why did they even create it?
Imagine trying to summarize humanity. Our sounds, our images, our music, and putting it all on a gold-plated record. That was the challenge for Carl Sagan and his team back in the 1970s.
That sounds like an impossible task. What did they choose to include?
It's a fascinating mix. There are greetings in 55 different languages, sounds of nature like wind, thunder, birds singing, even a baby crying.
I bet they included some Mozart and Beethoven too.
Of course. They put together a variety of music, From classical to folk blues to rock and roll. They even included Chuck Berry's Johnny B. Good, just in case aliens like to rock out.
We sent rock and roll into space. That's awesome. But seriously, what were the chances anyone would ever find this record? It's like throwing a message in a bottle into a vast ocean.
Honestly, the chances of extraterrestrials finding the golden record are incredibly small. Space is just too vast.
So it was more symbolic than a real attempt at communication.
I think that's a good way to put it. But even as a symbol, it's powerful. It shows our hope, our curiosity, our desire to connect with something beyond ourselves.
It's like a message to the universe, carrying our stories, our dreams, our hopes for the future. And who knows, maybe one day, billions of years from now, it'll be found and spark the imagination of another civilization.
That's the amazing thing about it. It represents the human spirit, our need to explore, to connect, share our story with the universe, even if we never get a response.
Welcome back to Cosmos in a Pod.
It's good to be back.
As we wrap up our deep dive into the Voyager missions, I'm feeling this sense of awe, but also a little bit of melancholy. These two tiny spacecraft, they were launched over 40 years ago, and they've revealed so much about space, and they've left us with these really big questions about, humanity's place in the universe.
It's been a pretty incredible journey. For the spacecraft and for our understanding of the cosmos, the Voyagers really pushed the boundaries of exploration, and they've inspired so many scientists and dreamers.
It's amazing to me how this technology from the 1970s has become so iconic. It represents this deep human drive to explore, to go beyond what we know and venture into the unknown.
It's that spirit of discovery that keeps us moving forward, that makes us question and wonder and look for answers beyond our own world. The Voyagers really embody that spirit more than almost any other mission.
And they've proven that even with older technology, we can still achieve amazing things. It's a testament to how clever the people were who designed and built them, and the dedication of the teams who've kept them running for so long.
I agree. The Voyagers remind us that exploration is a team effort. It takes brilliant minds and this constant pursuit of knowledge. And that same spirit of collaboration will keep driving us as we explore space in the future.
So looking ahead, what lessons from the Voyager missions can guide us in future explorations?
One big lesson is the importance of thinking long-term. The Voyagers were only supposed to last 5 years to study Jupiter and Saturn, but they've gone way beyond that and given us decades of incredible data. When we plan future missions, we need to think about more than just the immediate goals. We need to consider the potential for discoveries years down the line, and the legacy we'll leave for future generations.
That's a really good point. It also shows us that exploration is about the journey, not just the destination. The Voyagers have taught us there's always something new to learn, something new to discover, and that the search for knowledge never really ends.
Exactly. It's about accepting the unknown and being ready to be surprised by what we find. And the Voyagers have definitely done that over and over again.
It's not just about scientific discoveries either. It's about the inspiration, the wonder, the sense of awe that exploration brings.
You're right. The Voyagers have captured our imaginations and broadened our perspectives. They remind us that we're part of something so much bigger than ourselves, something that goes way beyond our planet.
As we say goodbye to these amazing explorers, it's good to remember Carl Sagan's words. He was so important to the Voyager missions. He said, "We are a way for the cosmos to know itself." And the Voyager probes, with their messages and music and images, they prove how true that is.
They symbolize our connection to the universe. They show us that we're not alone in this vastness.
Yeah.
And even though they'll eventually lose power, they'll keep drifting through space, carrying a part of humanity with them for billions of years.
So as the Voyagers continue on their silent journey into interstellar space, they carry with them our hopes and dreams, but also the essence of who we are, as explorers, as dreamers, as people who want to learn and understand.
Their legacy will keep inspiring us to push the boundaries of exploration, to reach for the stars, and to always keep asking questions about the mysteries of the universe.
Thank you for joining us on this incredible journey into the Voyager missions. It's been amazing to share this exploration with you.
The pleasure was all mine.
And remember, the exploration continues. There's still so much out there to discover, so many mysteries to unravel. So keep looking up, keep asking questions, and never stop exploring. For more cosmic adventures and mind-blowing discoveries, don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel. Until next time, keep exploring the wonders of the universe.